We all think of ourselves as basically honest, but the data shows that most of us slip tiny, everyday deceptions into our lives without even thinking about it. Behavioral economist Dan Ariely spent years testing this exact paradox. After studying roughly 30,000 people, he found that very few individuals are chronic, high-stakes liars. Instead, almost all of us cheat just a little bit. The standard model of lying assumed we use a rational cost-benefit analysis. We subconsciously weigh the tiny reward of a stolen pen against the risk of getting caught and punished. But human beings are more complicated than a simple risk equation. Unseen environmental forces, the influence of pure behavior, and deep psychological triggers actually override our rational decision-making when we choose to deceive. A simple lie triggers an expansive biological chain reaction. To pull off even the smallest falsehood, you are forcing your body to endure a measurable surge in computational strain. Your brain doesn't have a single switch that flips you from truth to deception mode. Instead, a lie demands the active, simultaneous coordination of multiple brain regions, consuming significant metabolic resources. Look at this functional map of the brain, specifically the prefrontal cortex. When you lie, this single region has to suppress the honest response, construct a fake narrative, monitor that story for consistency, and predict how the listener will react, all at the same time. As you can see highlighted here, the anterior cingulate cortex kicks in next. This is the brain's internal conflict monitor. It detects the glaring contradiction between what you know is true and what you are saying, immediately sounding neurological alarms. Following that alarm, the map shows activity moving to the amygdala. It calculates the social risk of getting caught and triggers an autonomic stress cascade. Your heart rate spikes and cortisol floods your system. Finally, watch this area light up, the insula. It reads those rising physiological stress signals and translates them into a physical sensation. It gives you that uncomfortable, sinking pit in your stomach that we experience as guilt. Juggling competing realities is exhausting. It creates a massive, intense cognitive overload that your biological hardware actively tries to avoid. Because the human brain is sensitive to energy consumption, it looks for ways to optimize that taxing process, making the exhausting task of deception easier. This happens through neuroplasticity. When you repeatedly lie, the neural pathways associated with dishonesty thicken and reconnect, physically strengthening the infrastructure for deception. Meanwhile, the amygdala undergoes a process called habituation. With every repeated lie, the brain dampens those emotional warning signals, shrinking your physiological stress response. In tandem with the amygdala, the insula becomes less sensitive. The physical discomfort and internal sensation of guilt slowly fade away the more often you lie. External factors accelerate this process. Experiencing ego depletion, fatigue from stress or sleep loss, watching peers lie without consequence, lowers your resistance to deceit further. This automation process ensures each subsequent lie requires less metabolic effort. The brain effectively optimizes itself for deceit, making dishonest behavior and therefore highly likely neurological response. But even with a highly optimized, habituated brain, humans face an evolutionary problem. When we lie, we still risk leaking physical cues to the people around us, people who have evolved highly sensitive radar to detect deception. Psychologist Paul Ekman spent his career cataloging these leaks. He identified what are known as micro-expressions, brief, involuntary flashes across the face, sometimes lasting less than half a second, that reveal a person's true hidden emotions when they lie. To bypass those physical tells and skip the heavy cognitive load of lying entirely, researchers propose that the brain developed a brilliant evolutionary workaround, the capacity for self-deception. If your brain can rewrite its own memory and genuinely believe the false narrative, the prefrontal cortex and the amygdala no longer register a conflict. The stress response never initiates, meaning the physical microexpressions completely disappear. This makes self-deception the most durable lie we can tell. Because the brain authors the falsehood and simultaneously acts as its own gullible audience, There is no external skepticism or corrective feedback to interrupt the process. We often treat honesty as a fixed moral virtue. In reality, it is a neurological capacity that requires constant exercise. If we do not actively prioritize the truth, the brain's drive for efficiency ensures that the person we deceive most successfully is ourselves.
Do you have any ideas for my next video? Just write them down in the comments below, and I will explain it in the next one. Don't forget to like and subscribe. Thank you so much for watching.